In 8.1 we did translations, which is a slide. Today we will do 8.2 reflections, which for most of you this will be just as easy. So reflection could also be known as a flip. It is a transformation of A to A prime such that a given line is a perpendicular bisector of A prime. So if I look here, the segment A prime is drawn. This line of reflection is its perpendicular bisector. So that means if I were to mark this, this is a 90-degree angle, and this side is congruent to that side. This is called the line of reflection there, because if you fold it, A would then be mapped directly onto or laying directly on A prime. To make a paper mask, Kathy folds the paper in half and marks a point, A, for an eye hole. She then cuts through the folded paper at A to make two eye holes, A and A prime. If A primed equals 4 centimeters total distance, find the distance between A and the fold line. So we talked about how this side would be congruent to this side. Well, if the total is 4 centimeters, that means one side would be 2 centimeters. And that would be our answer. Our next example is that Andrew wants to hang a square poster on his bedroom wall. He places a picture hanger at W. To get the poster to balance properly, he places a second picture hanger at W prime. Sorry about that. We'll try to ignore that. And we have picture hanger at W prime with the dotted vertical line as the line of reflection. If the distance between W and the vertical line is 3 inches, find W prime. So I know that if I folded it here, W prime would be somewhere in this location. We know that this has to split it evenly, so that means W prime would also be 3 inches from that line of reflection. That gives me then a total length from W to W prime as 6 inches. Okay, our next one here, Susan placed a cup on a table. She then placed cardboard on top of the cup and another cup upside down on top of the cardboard. The side view of ABCD, the cup below the cardboard, is shown. The cardboard is aligned with the x-axis. The side view of cup ABCD primed is a reflection of the side view of cup ABCD. Draw and label the side view of cup ABCD prime. So basically, this x-axis is a piece of cardboard. They're going to take a second cup, flip it upside down, and set it on that cardboard. So that means x is our line of reflection. Remember, everything is equal distance. Well, if this is our line of reflection, D zero distance from it, so is D prime, because they have to be the same distance from it. C is also the same location as C prime. A is 1, 2 from X, so we go the opposite direction to find A prime. B is 2, and so I go 2 up and get B prime. My cup then is going to look like this. Hopefully yours looks a little bit better. So if I look here, it says the distance from the x-axis. A and A primed are both 2 units away from it. B and B primed are also both 2 units away from it. C and C primed are 0 units because they are on the x-axis, and the same is true with D and D prime. Okay, our next example gets a little bit fancier with the shape. It says Layla is designing a star-shaped figure for a stencil. She wants the bottom half to be a reflection of the top half. She'll reflect it across the x-axis to draw the other half. Complete the design for her. So if I look here, I know that they're all going to have to be the same distance away. So Q was 4 up, so Q primed is going to be 4 down. P was on it, so it's still going to remain on it. I need to find another point. I'm going to label this point S. It's 1 up, so I need to go 1 down. So that would be S primed. This point I'm going to name T. So T primed would be 1 down from it. I'm going to try to use this, and I can't because it jumps it around, not sure why. So I'm just going to have to do my best job trying to draw a straight line, as will you. If you wanted to, technically you could get out a ruler. Oh, that one was really bad. Let's try that. Maybe I should do less talking and more drawing. And there we go. So over here they want us to find the coordinates. You have to change these. This should say P, Q, R, S, and I added T. So this would be P primes, Q primes, R prime, S prime, and T prime. So P was originally at -4, 0. Since it was laid on the line of reflection, it stays the exact same location, -4, 0. Q was up above it at 0, 4. Q prime then is at 0, -4. R was at 4, 0. R prime, because it was at on the line of reflection, remains the same at 4, 0. S was at -1, 1. S primed is at -1, -1. And T was at 1, 1. And T primed is at 1, -1. If we use these, we can use these to make a generalization. A reflection in the x-axis maps xy onto, if I look here, nothing changed there because it was on the line of reflection. Q, though, went from 0, 4 to 0, -4. So my y was the opposite. Here, nothing changed because it was already on the line of reflection. Again, on S, -1, -1, the x stayed the same, but the y is the opposite, 1, -1. And the same is true on T. So that means our generalization is that x remains the same, but the y is the negative y, or the inverse of y. So your reflection over the x-axis gives us x negative y. Okay, and our next one here says find the coordinates of the points after a reflection, and this time it says we're going to reflect it over the x-axis, so it's going to be the same distance from the x-axis. So D is 1 to the right, so I'm going to go 1 to the left for D prime. C was 1, 2, 3 over, 1, 2, 3 over, would give me C prime. B was 1, 2, 3 over, so B primed would be 3 over. And A was 1 over, so A primed is going to be 1 over. Do your best. Draw in your points. And now we do the coordinate figures over here. So if we look, A was at 1, 1. A primed was at -1, 1. So if I look there, Y's are the same this time, but the X's are the opposite. So let's see if that's true with the rest of them. B was at 3, 2. B primed is at -3, 2. So that is true for that one. C was at 3, 3. C primed is at -3, 3. And D is at 1, 4. And D primed is at -1, 4. So it was true for all of them. The X's this time are what changed. So a reflection of the y-axis on the map changes xy to -x, and the y stays the same. So our two generalizations for reflection when you use the x-axis and the y-axis, the x-axis maps xy onto x, and our y changes, -y, and the y-axis maps xy onto -xy. So those are your two generalizations for a reflection. Our last one here we're going to look at is the following. It says Mr. Patterson is building a double birdhouse, one next to the other. The vertices of the front of one house have the coordinates P30, Q63, R36, and S03. The front of the other birdhouse, PQRS primed, is a reflection of the first one in the y-axis. So if we remember our generalization for the y-axis from our last page, and sorry about that, is the following. we do negative x, y. So over here, if I fill in my information, the x-coordinates of the vertices are opposites. That's why it has the negative in front of it. Their y-coordinates are the same. So P was at 3, 0, and we said we're going to change all the x-coordinates to the opposite. And the y stays the same. Change it to the opposite, the y stays the same. Change it to the opposite, the y stays the same. Change it to the opposite, there is no opposite of 0. So that stays the same, 0, 3. Any point xy is mapped onto negative xy when reflected in the y-axis. We're almost done. We've had a few interruptions. Sorry about that. Guided practice, you need to look at page 62 to do number 1. And number 2 I have included on this. And your assignments, page 70 through 72, 1 through 6.